All right, let's get right into it. If you're an electrician or a plumber, you know there are certain things on a job that can make or break an inspection. And let me tell you, gas pipe bonding is way up on that list. This isn't just about checking a box for the inspector, it's about real-world safety. So we're going to break down exactly what you need to know to get this right every single time.
Here's the game plan. First, we'll talk about the real danger we're trying to prevent. Then, we'll clear up the difference between bonding and grounding once and for all. After that, we'll get practical with a guide for different pipes, run through a real job site scenario, and then wrap it all up with some key takeaways you can use tomorrow.
Okay, first up, the danger. You know, a lot of guys think this is all about a lightning bolt hitting the house directly, but that's actually not the main threat we're worried about here. It's something a little more sneaky.
So let me ask you this. What do you figure is the #1 electrical threat to gas pipes in a building? A bad appliance, a short circuit, a direct lightning strike? Well, the answer might actually surprise you.
It's indirect lightning. Yeah, a strike that happens miles away can send a surge of energy through the power grid. That energy can light up all the metal systems in a house. You know, the copper water lines, the ductwork, you name it. And if your gas pipe isn't electrically tied to those other systems, that energy can literally jump through the air looking for a path. That's called an arc, and it can puncture a gas line, causing a leak and a fire. It's a disaster waiting to happen.
Hey, don't just take my word for it. The manufacturers, like HomeFlex, say it loud and clear. Proper bonding may significantly reduce the risk of damage, including fire. So preventing that electrical arc, that's the whole ballgame.
This brings us to probably the single biggest point of confusion out there, and the #1 reason I see for failed inspections: the difference between bonding and grounding. They are not the same thing, and if you mix them up, you're going to have a bad day with the inspector.
Okay, so what is bonding? Simply put, bonding connects things to each other. Think of it like you're building an electrical bridge between all the metal systems in the house: the gas pipe, the water pipes, the electrical panel itself. The whole point is to get everything to the same electrical level, the same potential, so there's no reason for that dangerous electricity to jump from one thing to another.
Now, a grounding electrode, that's a completely different animal. That's about connecting the whole electrical system to the earth. We're talking about your ground rods, your water pipe ground. Its job is totally different. It's there to give a massive fault current, like from a lightning strike, a path to get safely into the ground. So here's the bottom line. Let's put it side by side. Bonding connects stuff together. Grounding connects stuff to the dirt. And this last point here, it is non-negotiable. The code, both NEC and NFPA 54, is crystal clear. Gas pipes have to be bonded, but you are never, ever allowed to use a gas pipe as a grounding electrode.
Okay, theory's over, let's get our hands dirty. We know we have to bond it, but how? Well, this is where you really have to know your stuff, because the right way to do it changes completely depending on what kind of gas pipe you're dealing with.
You've basically got two main players on the field. For old-school rigid pipe, black steel, the bond is usually already taken care of. That green or bare wire in the appliance's power cord, the equipment grounding conductor, does the job, and this is a huge but, if you see that standard yellow CSST, that flexible stuff, the game totally changes. That little ground wire in the cord is not enough. It absolutely requires its own separate direct bond.
And when the code says a separate bond, it gets super specific. There is one magic number you have to burn into your brain for standard CSD. Number 6. The bonding wire has to be a minimum of number 6 AWG copper. Not number 12, not number 10. It's got to be number 6 or bigger. Don't forget that.
And look, you don't have to take it from me. This picture is straight out of the National Fuel Gas Code. It points right to the CSST and says it in plain English: the bonding jumper shall not be smaller than 6 AWG copper wire. It doesn't get any clearer than that, folks.
So let's walk through the install. How do you do it right? It's pretty simple. Step 1. You're going to get a proper UL 467 listed bonding clamp and attach it to the pipe or the first fitting. Step 2. If you're clamping onto a piece of black iron pipe, you have to sand off the paint to get to bare metal. You need a good connection. Step 3. Run your number 6 copper wire from that clamp. And Step 4. Land that wire on the grounding bus bar inside the electrical panel. That's it. Simple, direct, and totally code compliant.
Okay, time to put you in the driver's seat. We've covered the why and the how, so let's run through a quick field check. I'll give you the specs from a real job, and you tell me if it passes or fails.
Here's the scene. We're at a house with a 200 amp service. The grounding system is solid. Number 4 copper to the water pipe, number 6 to a couple of ground rods. We've got 2 appliances to look at: a natural gas furnace that's piped with black steel,
and a propane appliance that's fed with that standard yellow CSST.
All right, first question for you. Let's look at that furnace on the black steel pipe. Based on what we've talked about, is this installation compliant, pass or fail?
And the verdict is, yes, that's a pass. If you said pass, you're right on the money. Because it's rigid pipe, that number 12 equipment grounding conductor inside the furnace's power cord provides an effective bond. No extra wires needed. Good to go.
Okay, round 2. Now what about that other appliance? The one that's being fed by the yellow CSST? Remember, it's also got a regular power cord with a number 12 ground wire. Is this one compliant?
And this one is a big, fat no. This is a failed inspection all day long. As we've been saying, for standard CSST, that little equipment ground wire is not good enough. This installation is missing its dedicated #6 copper bonding jumper. That's a code violation and a serious safety hazard.
Now, just when you think you've got it all memorized, the industry throws a curveball. What about that newer black-jacketed CSST you're starting to see on more and more jobs? So this is the new kid on the block, arc-resistant CSST. It has this special conductive jacket that's literally designed to spread out the energy from an electrical strike, making it way tougher. And the big sales pitch? You might not need to run that separate number 6 bonding wire. Which, of course, leads to the million-dollar question every installer wants to know. Can I save myself the time and material and just skip that number 6 bond if I use the black stuff? The answer is maybe. And I know that's frustrating, but it's the truth. It is not a simple yes or no. You have to do your homework. You need to check the product's official listing and have the manufacturer's instructions physically in your hand. And most importantly, you need to know what your local inspector, the AHJ, is going to say. They have the final word. So for all you plumbers out there, using an approved arc-resistant product might save you a call to the electrician. But for everyone, if there's any doubt in your mind at all, just bond it. It's the safest bet every single time. Okay, I know that was a lot of code talk and section numbers, so let's boil it all down into a super simple cheat sheet you can actually use out in the field. Here it is, plain and simple. Black steel pipe, the equipment ground wire, the EGC, is almost always enough. Standard yellow CSST, this is non-negotiable. You absolutely must install a separate number 6 bond. And the new arc-resistant black CSST, that's the big maybe. You might be able to skip the bond, but only if the product listing, the manufacturer, and your local inspector all say it's okay.
So let's bring it all home. I want to give you some clear, actionable advice that you can take to your very next job to make sure you pass that inspection the first time, every time.
For all you electricians out there, here's your mental checklist. From now on, when you see that yellow CSST jacket, your first thought should be, where's the bond? Then you verify it. Is the wire at least a #6 copper? Is that clamp UL listed for bonding? And where does it land? Make sure it goes right to that grounding bus in the panel.
And for all the plumbers, here's how you can save yourself a massive headache and avoid those callbacks. If you install standard yellow CSST, you have to plan on getting an electrician in there to install the bond, period. Or, here's a pro tip, consider using an arc-resistant CSST, which usually has a black jacket. A lot of those are listed in a way that doesn't require the extra bond, which could save you a step and a phone call. But no matter what, your local inspector has the final say, so always check with your AHJ. So I'll leave you with this to think about. On that last job you were on, was the gas line really bonded, or was it just grounded through the appliance? Now you know the difference. And now you know why getting it right isn't just about passing inspection. It's about protecting property and maybe even saving a life.